Okay, I hope this works, and I don't know how good the quality is here, but I am recording using Open Broadcaster software on Linux. I'm going to show you my screen, and okay, there's the program here, and here's my desktop. This is my desktop. These are various icons I can click. I like this very minimal desktop. See, I right-click there, it shows me all kinds of things. I have options. I can create folders. I can create documents using various programs. Here's Open with Dolphin. Now, Dolphin is the file manager, and it's a really cool file manager. See, it opens up my desktop within the file manager. But the same effect can be achieved by simply going here and clicking. Okay, so here is my home directory, and there's nothing in these folders here because, at least I don't think so. Oh, there are a few files here. I wonder what happens. I don't even know here. Let's see here. What happens if I play this? I think these are video files from when I previously recorded. Okay, I hope this works, and I don't know. Whoa, that's freaky. Okay, yeah, I do not know. Let's see, am I still recording? Yeah. Let's see here. Let's try a different file. I think this, oh yeah, that was a very short recording. So, yeah, I can play a video file that I've recorded before. Okay, so there are some files here. Anyway, I'm going to show you my programs and how I can easily, I'm talking easily, compile these things. Okay, so I have a shortcut. This is, now I have full access to my Windows installation. This is a dual boot system. You've seen all these folders before. This is normally in my home folder inside my msys installation when I'm running Windows. But it is on the C drive or SDA1. So here's the thing. I have various things, and anybody who's watched my recent videos knows that I've been using OpenGL. I have a whole big thing, like for example, this is kind of out of date, but here were some, this is a text file here, and this is some commands I was using to compile my free glue program. It was really cool. So anyway, enough of that. This is the Kate text editor. Okay, anyway. Okay, so here's what I'm going to show you. I'm going to go to, this is the temp folder. Now, this is the folder where I basically, when I'm working and adding features to my free glue version of my Polygon program, this is the folder I'm working from, usually on Windows, but this time I'm going to show you how I compile and run this code here. So I'm going to press F4 on my keyboard, and all of a sudden we have a terminal right below here, and you can see it's in that folder. So if I do ls, the names of the files and the folder named O are the same in the terminal with the ls command as it's showing in the file manager. So now what happens if I type make? Here we have my spinning triangle. This is Chastity's Polygon OpenGL, although I am considering calling this the Polygon Playground, and you're going to see why. This is my program that I wrote, and there's a lot of code involved, but let me show you how it works. Okay, I can press various keys, and I can change the color of this triangle, but I can change the number of sides that this polygon has. But that's not all. Here's an octagon, okay? So, I can change the draw method. See, I've changed it so now it only draws lines. I can change it back to the other method. I can change that. This draws lines from the center of the octagon to the corners, but doesn't draw between the corners. This only draws the actual pixels. You might not be able to see it because it's very small, but I'm going to show you something. I can do some incredible stuff. Okay, first of all, let's change back to line mode. Now watch this. I can shrink it. I'm pressing the semicolon key and I'm shrinking the polygon. And I can increase it again, and that's not all. I can move it. If I press the H key, it slowly moves to the left, 1 pixel at a time each frame. If I push J, it goes down slowly, but I invented a quicker method of moving it. I can click the mouse and move the polygon. The center of the polygon becomes wherever I click at. So I can move the polygon anywhere I like. But there's something else. If I right click, look at this. You see that? I just made a ring. See, here's what happens is ordinarily it clears the screen to black each frame and then redraws it. But now watch this. If I right click and then hold L, look at that. You see that? It is drawing, but it's not erasing the screen. It's simply drawing over rather than erasing the screen. But I can get much, much freakier than that. I can change the color. I can move the polygon wherever I want and change the color. Now let's erase the screen again. And okay, let's start out. Let's make it black so you don't see it. Then let's make it blue. Then let's turn off the screen clearing. I'm going to right click and then I'm going to hold of that, and then let's change it to green, and then let's continue moving for a while. Then let's change it to cyan and keep moving for a while. Then let's change it to red and keep moving for a while. And then let's change it to magenta, and then let's change it to yellow. Yay! Now let's change it back to blue again, and let's start going back this way. It's kind of freaky, isn't it? Yeah. But there's much more I can do with this. It's really cool. So first of all, if I press E, it will switch to filled star polygon mode, but I can change the steps. So I can change the, now it's doing a skip of 2 for an 8-sided polygon. Here's a skip of 3. Now, you might not understand the skip part. Okay, so watch this. Here we have an 8-sided polygon, then I'm pressing the equal sign, and it uses a step of 2. So in other words, it's drawing every other 2, so it creates 2 squares. But I can make it 3, and it looks like that. But I'm going to show you something you're probably more familiar with. Okay, first of all, let's change this back to 1. Then let's reduce this back to 5. Now this is a pentagon, the 5-sided polygon. Now what happens if I have a 5-sided polygon and I change the step to 2? We get a pentagram. That's what it gets. I can change the number of points to 6 and we get a hexagram. You see how this works? This is my star polygon method. Now if I press Q, it switches to just regular convex filled. W is regular convex, just the lines, outline. E is star polygon mode, filled. R is just star polygon, just outline. And then here's T, where it just draws the lines there. And then this is where it gets really cool. Now, here we have 5 points here. Let's make this radius just slightly, I can move this anywhere. But now, let's turn off, I'm going to right click and turn off the screen clearing. Now look at that. Now, because this always spins, I haven't added an option to turn it off. But now what happens if I try to shrink it while it draws that? You see that? See what I got there? It keeps drawing the pixels, but then it just goes freaky. Now is that beautiful or what? So you see, what I have done here is I have created a playground, an art environment. So what happens now, let's change this back to a triangle. First of all, let's change this to just the outline of a triangle. Wait, okay, I did not mean to press F12. Okay, here is a triangle. Now, here's what I'm going to do. Let's, this triangle is currently white. but let's change it to blue, and then, oh, that's right, I need to turn off the, okay, yeah. I'm going to turn off the screen clearing. Now you see that? You see what happens there? I just changed the color to blue, and it just keeps drawing over whatever was there before. This is my amazing Polygon program. It's super cool, but it can go much more advanced. So let's change the color and then shrink it slow. Oh, I accidentally am. Wait, I'm making it bigger. Wait, how did I? Oh wait a minute. Okay, let me restart this program. I think I screwed it up. Okay, okay. So we have a triangle. Let's show what happens if I shrink it while it's going white. You see that? It's slowly shrinking like that. And now let's change to blue, and then let's increase the size of it. You see, it's drawing the polygon but not erasing the screen. So let's make it really nice and big as it's blue. Then let's change the color to green and start shrinking it again. You see what we're getting? It's absolutely freaky. Yeah. Man, I'm like making an eyeball. This is so weird. Okay. Let's start making it bigger as we change some of the colors to red. You see how freaky that is? That's just like totally freaky. Now we're adding some magenta, because you know my favorite 8 colors, there is a method to this madness. So you see, the more color I add, the freakier this thing gets. Now keep in mind that I can do some incredible things here. So there's white there at the center. Now what happens if I click here? Now it's white. Now let's change this back to solid polygon mode, and then let's change this to be black. You see that? I've made it black now. Let's make it a little bigger so it erases that area, and then I'm going to hold the L key and make it go right, and pretty soon, you see what it's doing? It's drawing black over that area. So it's just erasing slowly. But I can speed it up. I can just click here, erase that, click here, click there. But then I can change the color to cyan. You can just you see, I'm going absolutely nuts. There's like almost no limitations to what this program is capable of. And it's super fast actually. In fact, here's the trick. Now, my computer is old and it's very slow when running a lot of games, but now that I'm running Linux, I'm getting enhanced performance. I'm getting much enhanced performance. It's really cool. So anyway, you saw how easy it was to compile and run that here. Now, I'm just going to give you a brief look at the source code here. So, first of all, here's my main.c file. You may have seen some of this code before, but here is a text editor named Kate. And you see here, we have my source code of the main.c file. And this has everything, all of the OpenGL code. It has the free glute code that determines what happens when the mouse is clicked, what happens when very specific keys on the keyboard are pressed. I wrote all of this huge code in this file. And notice that I also have a terminal here. Isn't that freaky? I actually have this here as well. So, yeah. And then this is very weird because the folder it's showing there is not the one I'm currently using, but yeah, you get the basic idea. And then let's X out of there, and then I'll show you the GLFW Polygon header. This is the file that has everything. Let's see, how do I want to close that because I just want a full screen view of this. So here we have all of the code that goes into making the regular polygon. It uses the math to get the points, and then yeah, it's just absolutely freaky. So I have several different functions that draw using those same points in various ways, as I showed you while running the program. And there are even some other functions I have in here that I'm not really using in the program, but I just have here in case I feel like using them. Now, what you just saw here was the free glute version. And there it is. See, this is the executable, and it says chassis Polygon OpenGL. And that was the original version of the program, but I have something else to show you, something very special I did yesterday. Okay, let's go. I'm going to show, now pay attention to what happens in the terminal. So first of all, I'm going to go up a directory to GL, and did you notice that it's changing directory? As I click on different directories, the terminal window changes to that directory. So first of all, let's go to Hello window, and okay, and then let's try make. Ah, interesting. Let's see, let's look at the make file, cat make file. Okay, so in this case, this make file is set up a little bit differently, but okay, so make opengl. You know what? I think I messed it up because that make file is not properly configured. Oh, I know what to do. Okay, I know what to do because I have a certain setup. Okay, what I'm going to do is I'm going to go to this folder because this make file is correct. And then let's copy that make file over to this folder, and then I'm going to overwrite the one that's there. I just copied a file using the file manager. Now let's try typing make again. Now you see this, we have a window with a title that says GLFW, but it doesn't do anything else. That's because it's a very basic program. If you look at the source of this this is using the library GLFW, and this just has a very few callbacks. A callback for the escape key, a main function that initializes OpenGL, it creates a window, creates an OpenGL context, but it's actually very short. But I started with this. I was learning to use GLFW, which is it's similar to FreeGloop, but it has a few different features. So now, okay, I'm going to close that one. Now let's go back to the folder that I was just in. This is GLFW regpoly. Now watch this. Now we're in this folder. Let's clear the screen here by typing clear, and then let's type make here. Now you see that? It's my spinning polygon, and it behaves exactly the same using GLFW. So I can change the colors, I can change the number of points, I can do all sorts of freaky stuff, you know. Yeah, like just for an example, I'll show you. Right click. Let's make some blue. Yeah, let's make some green. Let's make some cyan. Let's make some red and some magenta and yellow, and then white. Let's make it white that expands. You see that? So this program behaves the exact same way, except notice the window says chassis Polygon OpenGL using GLFW. Well, that's because you get this. Look at the source code here. Here's our main.c file. Now, some things look the same, but other things are different. Notice here that we have, in fact, I'm going to close this terminal by typing exit, so you get a full screen of the source. This is the GLFW version of the exact same program. And how does it work? Well, it's very simple. The program works almost identically, but I had to change things. So I had to change, it has an error callback, and it has, these are the different keyboard shortcuts. Notice that they all say GLFW key, 0, 1, all these things. So these are constants that are for certain keys that are pressed on the keyboard. So I basically copy-pasted all the code from my FreeGloop version and then changed the constants to match the GLFW library. Now look here, I have a mouse button callback, and here's the clear switch that determines whether we clear the screen or not. Notice how if the right mouse button is clicked here, it switches on or off the clear switch, and notice that it sets the polygon center X and Y position to wherever the mouse is clicked. That's because this function is called every time I click the mouse, and then it gets the position of the cursor where it's currently at, and then if the action is pressed, meaning the key on the mouse is pressed down, then it does this code based on whether it's the left or right button. And here's my main function. The main function is a little bit smaller here, but here we have it. We declare a window, we print hello world, and we set the error callback. And this is just initializing GLFW, and then we set which OpenGL version are we using. Then we create a window, set up the context, the callbacks. It works the exact same way as the free-glue version of the program did, but it's but a lot of code was just copy-pasted, and then others were modified to work with GLFW. So it's a different language basically. The exact action is the same, but the syntax is different. The names of the functions are different, but the names of the variables that I use for my polygon and all that stuff, well, that is pretty much the same because it was just copy and pasted over from the other project. And here I even have some compiling commands that I use on Linux and Windows, which are also in the makefile, by the way. So like, for example, if we look at the makefile here, notice here we have the makefile, and this is the rule for Linux. It's at the top, so whenever I type make, it automatically does the Linux version. If I'm on Windows, I have to specifically select a different rule. But notice we have this tab that has the makefile, and then we have, if I go back to this tab, we go back to main.c. Now let's open one more tab, and look at this. This file, does this look familiar? That's right, because all I did was I copied over the exact same source file. The header file for all my Polygon-related code was simply copied over from the directory where the FreeGlue project was. So nothing in here has changed. This whole file is all the same because there is nothing in here specific to FreeGlue. It uses only the standard math library. All the variables are the same, the functions are identical. Not a single byte of the file is any different than it was in the other folder. And it uses only legacy OpenGL code. And some people might say, well, why are you using legacy OpenGL? Why aren't you using the modern stuff? And I'm like, okay, first of all, because I haven't learned it yet. Second of all, because every code example of using the modern OpenGL code, using shaders and all this stuff, is like 5 times as long. The source code is 5 times as long doing it that way as it is simply using, GLBegin, GLVertex, and GLEnd. That's all that I do because I'm just trying to draw a polygon. All it does when I draw a polygon is we already have the points set up from the other math, so we simply GLBegin, and then we loop through each of the corners of the polygon and do GLVertex, and then we do GLEnd. And then you see over here, there's basically a main loop, and each time it clears the screen. Depending on whether the clear switch is active, it may clear the screen, and it calls polyfunc. And polyfunc is a function pointer. And then here's the code that makes the polygon spin. It increments the radians, the rotation, swaps the buffers so that it updates the window contents to match what was recently drawn, and then it checks for events. Now the brilliance of this program, and it works the exact same way, whether I'm using GLFW or whether I'm using FreeGlue. In both cases, notice that the draw methods were defined by the keys Q, W, E, R, T, and Y. Well, here's how it works. There's a function pointer named polyfunc, and by setting the polyfunc pointer equal to these different function names, it changes with draw operation. So if you look carefully, right below GLBBM polygon here is polyfunc. It's a void function pointer, and we set it equal at the start to GLBBM polygon. So it starts out with this default method, but if I press certain keys, it will change to these other functions defined below. And in the comments, I describe what type of thing they do. So I actually used a function pointer. And here's the thing is that I'm really good at pointers, okay? It's really cool. One of the best features of the C programming language is pointers, and I use pointers all the time. In fact, let me just show you an example code. Now, I actually did write a function. The videos I upload to YouTube of me making things using my program were actually done using some cool stuff. Now, here is a function that saves the pixels from the window. This is an OpenGL call, actually. It reads the pixels from the window, and then it stores them as an unsigned byte array of RGBA values, so red, green, blue, alpha in that order. So this function saves the entire image pixel array into this global array. And then this function down here is a custom one that I wrote that saves it to a bitmap file. So this saves 24 BPP bitmap files. So what it does is it has a pointer. The pointer, which is GLU byte, so it's an unsigned byte pointer, and so it points to that array, and then it simply cycles through the entire array and then accesses them by index. So notice that they're in the order red, green, and blue. But when you're writing Windows bitmap files, it does it in the order blue, green, and then red. So that's why we go 2, 1, 0. And then it increments the pointer by 4, so it goes to the next pixel. So it's skipping the alpha value because the alpha value is not used in a 24 bits per pixel thing. So this was actually copied from my BBM library. And I even have another function that saves smaller bitmap files using a color palette instead. I made this one later. And it works in a very similar way as well. It's just that it's slightly different the way it operates because it uses some more complicated math. But you see the basic thing is the same. So anyway, that is because that was all my own code based on understanding the bitmap format. It's actually easier to do ppm files are probably the easiest. I haven't copied that over yet, but I could save ppm files if I wanted to, if I just copied over the code and then modify it to work with OpenGL. But this is all standard library stuff, my own code, and OpenGL stuff. I like using OpenGL because it's easy, at least using legacy. I don't understand the shader stuff yet. Maybe I'll learn that, but while I have time, I go back to work on the 16th. So while I have time, I've been working on my Polygon program, and it's very, very cool. Oh, and at the end of my header file, I have all of this stuff that shows different links where I'm running OpenGL, and it shows what compiling commands I use for my free glute version, and then with the GLFW. So I have two libraries that I use. So I can use either free glute or I can use GLFW, but both let me create a window, open up an OpenGL context, and regardless of which I do, I have a program. So this is the one using GLFW, but it's just very pretty, it's just super cool. I can change this to whatever I want. Yeah. So just one little more demo. So yeah. Ooh, yeah. cool. Whoa, it's freaky. Yeah. Yeah, that's just so cool. Anyway, you get the idea now. I've talked long enough, but I am just very impressed with this Linux distribution here. Okay, let's X out of there. Let's close my manager. Let's see. We're still recording. I've been going for about 30 minutes. But before I end this recording, how about I continue? We'll make this about an hour long, okay? I still have more I want to show you. So, let's actually, I know what I'll do. I'm going to go over here and I'm going to show you my applications. So, I have several games here. But there's one that I'm going to show you. I have not ever tried to play this before. So let's see what happens. It's called Pink Pony. Okay. This looks cute. I'm going to try something here. I'm going to turn off my microphone so that only the video game music plays. Okay, that was weird. I don't know how to play that game, and the interface is confusing. I'll have to take time to figure that out. But anyway, this has been me showing you my computer programming environment on Linux. It's actually very cool because I can open a file manager, and then I can just instantly open up a terminal and then type make, and the program in that directory will compile and run because I've already set up the make file. People think the command line is hard, and well, it is when you're starting at first, but what you do is you simply, once you know the compiling command you use for compiling your C or C++ code or whatever else, well, you just set up a make file like I did. And you saw the make file is very simple, and there's a manual. There's a manual on the website for new make to use that, but there's also the FreeBSD developer's handbook, and I learned a lot from there because I was using FreeBSD, but the information about the section on make files for new make applies to any Linux or Unix distribution. So there's a lot of information there, and I hope that this video has inspired people to learn using Linux. It's actually super cool, and I can play games, I can do my computer programming. I may not be booting back into Windows for a while. Now this computer is still old and it has limitations. I actually got the Java version of Minecraft running on here before, which was really impressive. It still had lag because, you know, what can you expect? It's a super old computer. And I found out recently that a large amount of what determines how fast a computer is at running video games has to do with the graphics processing unit. Not only is there a CPU, the central processing unit, but there's also a graphics processing unit, or GPU. And a newer GPU is going to mean faster speed at drawing graphics, and OpenGL interacts with it, but you saw how fast those programs were that I wrote using OpenGL. And also, those have coding delays in them. If I take out the delays, the polygon spins so fast that I can barely see, like my eyes can barely catch up with it. It's incredible. So really, my computer is more than fast enough to draw a single polygon 30 or even 60 times per second on my screen. And in fact, at a modern computer, they can play the modern graphics intense 3D games and stuff, is probably 100 times more powerful than the old laptop I bought in 2012 that I'm still using. And I also ordered the Pinebook Pro, and I don't know yet when that will be delivered, but it's going to be delivered to my mom's house because they're package thieves that steal anything that I have delivered to my apartment, which is sad that I have crime in my neighborhood, but hey, you know what? This world is evil, full of evil people. But I'm trying to enjoy my life. I had surgery back on September 17th, and I'm recovering, and every day I'm reading programming manuals. I've been reading the FreeGlue documentation. I've been reading the GLFW documentation. There's even something else called Raylib that I'm curious about, and I may try eventually. But right now I'm so busy with GLFW and FreeGlue writing OpenGL programs, and it's exciting. It's exciting that I can create a window and then I can draw a polygon to it, and I can draw anything. I can draw lines from anywhere to anywhere. In fact, if I really wanted to, it would not be too hard to create a simple program similar to what I have, but that draws a line where the user clicks one place, like you click one place and then you click another place and it draws a line between each place you click. That would actually be super cool. But basically, I can do everything with OpenGL that I could do using SDL or Allegro. So if I wanted to recreate my Cycleband clone, I could do that, probably using OpenGL with either FreeGlue or GLFW, and I'm still deciding which of the two libraries I like better, because both of them are pretty good, and I don't really see a performance difference. I think it's more of a style preference, so we'll see which style I like. But there are other programming languages, there are other graphics libraries, there's so many. In fact, there's more on Linux that I have access to than I did running Windows 10. And Windows 10 is great sometimes if you need to use Skype and stuff like that, but I plan on doing the majority of my programming using Linux from now on, especially once my Pinebook Pro comes. And now what I'm using here is Q4OS, and it's a dual boot system I have where Windows 10 and Q4OS are actually running on the same hard disk. But the Pinebook Pro comes with Manjaro Linux, which is actually an Arch Linux-based distribution. And for those of you who aren't really tech nerds and know about the different Linux distributions, here's what it basically amounts to. I'm on Debian with Q4OS. It's Debian-based, so if I want to install something, it's like apt install and then the name of the package. Where in Arch Linux, it uses the Pacman package manager, which is what you saw me using under msys. So it's like, Pacman-S in the name of the package, and S stands for sync. So you can just install packages. There's also commands for searching the package repository as well. So it would be just as easy to install things on my new Pinebook Pro once I get it as it was to install things under msys. It's like, I know the commands from a few years of experience what to type. Plus, all the modern distributions have graphical package managers. For example, there's Synaptic on this one, on Q4OS. And it's really cool. So that's how I installed a lot of development packages. So I searched for FreeGlue and I searched for GLFW. And while I was at it, I installed all of the development libraries for SDL, SFML, and Allegro. So all of the graphics libraries that I've previously done programming with, I installed them all. And it's incredible. So now I have access to more development tools, and I also have tons of IDEs, text editors, video games. I have so much loaded onto this dual boot Linux distribution, far more than I could ever live long enough to use. So I'm very happy with my computer setup. I can do anything in Windows except play games, really, because this computer is too old to even run Minecraft Windows 10 edition anymore. It's so sad. So eventually I probably will get a brand new hardware computer with Windows 10 and play Minecraft on it, but then I will still use it to dual boot into Linux just as I'm doing now. Though in the meantime, my Pinebook Pro will keep me busy for my Linux needs, because that will be newer and faster than even what I can do on this laptop. Maybe you can run the Java edition of Minecraft faster than this computer. That would be something really cool. So I'm going to enjoy my new laptop, but I won't have as much time to do my programming or play video games once I go back to work. So that's why I'm enjoying this time the best I can. So anyway, I hope somebody has enjoyed this programming rant and Linux rant, but it wasn't just a rant. I actually showed you some cool code, and some of the I know there's going to be a few programmers out there who actually understand my programming code, who are going to have much more experience in OpenGL than I am, and they're probably going, why does this guy use legacy OpenGL? But you got to consider, sometimes things just work. Sometimes things work. It draws a polygon to the screen where I want, and that's all I really care about. I haven't created like a massive video game, and after I create a massive video game that people actually want to play, then if I need to learn modern OpenGL to make it run faster somehow, then maybe, but I don't see the need yet for that. So I'm going to do programming the way I like, using legacy OpenGL and lots of global variables, because it works. Anyway, that's all I have to say for now. But hopefully this video turned out well, and you get to see why I love Linux so much and why it's good for programmers.